All right, welcome to the build.
Rather than a forward back pass in a diffusion model, this is an image joint embedding model. Basically, the model is trained to predict what will be represented in multiple spaces or areas of this image. So you've got an image of a dog here, and this is the context, but half of its face and half of its neck's broken off, right? And the model then attempts to predict, based on its understanding of like a visual latent space representation of concepts, what will actually render down and make the most sense or complete the image concept within those spaces as a prediction into that image outcome of a dog, right? That's the context, that's the target. That's in an image context. This one is in a video context, so it's doing it on multiple frames at a time. And there's basically like a pass, which is different to how a diffusion model works, a video diffusion or an image diffusion model works, right? This also then applies as a concept to predicting like motion in the world. Like this is what we do. Like, so if you were looking at a ball rolling across a desk, right? And it went behind a cardboard box and you could see it as a human, you basically have a joint embedding architecture. You're like, I know what a ball is, I know what the box is, I can see that it's on a desk, and I can see the motion, and my embedding, effectively my high level embedding model could basically see what the low energy reference information is to predict the outcome of when the ball will emerge from behind the box as it rolls across the desk, right? Because I can use those concept of motion, concept of a ball, the fact that it's rolling at this pace to predict. And then I could basically say, all right, 2 seconds, there it is. And then it comes out the other side. That's a different way to predict, like say in that case, like what's happening in the world around me than a diffusion model is, where it's just like going through all of the potential variations of pixels to come up with a representation. Mm-hmm. And then in some cases reasoning over the top of it. It's much more human-like in that, like, all right, these are the things that matter in this image. I can reason over, I can see the energy density of the things that matter. I can reason over what's going on using this representation, and then I can make an accurate prediction of what's going to happen out of that, whether it's based on a request, so create a video of a skateboarder jumping, or it might be, tell me what you think is going to happen to the S&P over the S&P 500 over the next, 30 to 60 days.
Yeah.
All right, welcome to the build.